Hey there, do you know that you can generate electricity from just about any natural source? Serious? No JK. Serious. So, seeing how Singapore is an island country, my group, me, which is Naeem, Jay, Hongwei, and Xing, we would like to share with you on how we can generate electricity from the ocean. In this video, we will share with you two methods on how we can achieve that. The first being from generating electricity from the waves, which is wave energy, and generating electricity through the temperature gradient of the ocean, which is the ocean thermal energy. So, sit back and enjoy the show. Firstly, let's look at wave energy. Basically, the main principle is that you use the kinetic energy produced by waves to run a turbine that will in turn generate electricity, and then this electricity can be used. Let's look at the working principle of how wave energy can be generated into electricity.
To generate electricity, we need energy. So where does the energy comes from? It comes from the upwards and downwards movement of the wave, which pushes the air through the turbine, causing it to spin. The kinetic energy in the turbine is then converted to electrical energy. Concurrently, there are also check valves to allow the free movement of the air in the compartment. So, in an electrical generating farm, how many buoys do you think we need? Just 4 will do. Just kidding. We need hundreds of them. In this case, the working principle is slightly different from just now. This time round, it is slightly special. Water will now enter from the bottom, and the movement of the buoy acts as a water piston pump to push the water into the storage tank. The water will then flow down the pipeline to spin the turbine, which will then generate electricity for you and me.
So, the advantages of using wave energy is that first, it is ideal for island countries like our very own Singapore or countries with large surrounding water bodies such as the Mediterranean Sea, Baltic Sea or the Black Sea. Next, it generates electricity at a smaller scale since it uses individual piston pumps to generate electricity, meaning it can be used for more refined usages. It is consistent, seeing how waves are generated constantly throughout the year. It is a form of natural energy, one that does not need production that pollutes the environment. Furthermore, waves are abundant. It is everywhere and it can never run out. At any point of time, there is a force acting on the ocean that will produce waves. Lastly, waves are a renewable source of energy. On the other hand, the disadvantages are that the installation costs are high. Landlocked countries without huge water bodies are unable to benefit much. There is also a high tendency of being opposed by environmental groups, seeing how the constructions of many piston pumps and turbines on the surface of the water are unsightly and might also cause harm to the aquatic life. Lastly, waves, although they are consistent and occur all the time, the magnitude or the degree to which it occurs is highly dependent on the weather. A clear weather would generate slightly calmer waves as compared to a very turbulent weather.
Ocean thermal energy conversion. It is a marine renewable energy technology which uses temperature difference between cold deep and warm surface seawater to run a heat engine and produce useful work in the form of electricity in our case. It is also a base load electricity generation system. How does the ocean thermal energy conversion works? Firstly, it consists of an evaporator, a condenser, which is used to vaporize and condense a working fluid. There is also a turbine to generate electricity. A working fluid is required to drive the turbine. You must be wondering, how does the working fluid drive the turbine? Basically, the vapor of working fluid expands and drives the turbine coupled to a generator. The vapor then goes into the condenser to be cooled, where the temperature of the seawater is 5 degrees Celsius. It is then pumped back into the evaporator to vaporize the fluid where the temperature of seawater is 26 degrees Celsius. This creates a continuous electricity generating cycle. Moreover, to increase the efficiency of the turbine, larger temperature difference would be better.
For ocean thermal conversion, firstly, the plus points are that with circulation of water, cold fresh water can be obtained for uses like air conditioning or drinking. There are also no emissions generated at all from ocean thermal conversion, since water is just being circulated. It is also able to generate huge amounts of electricity in one go, proving it suitable for large-scale users. As with wave energy, it is also renewable. It is consistent since it depends on the temperature gradient of the seafloor to the surface, and in most cases, there is a constant temperature gradient. However, this depends on the climate itself. This will be explained shortly. Energy conversion by ocean thermal energy also carries some significant drawbacks. Firstly, following wave energy, installation is costly and it is also not suitable for landlocked countries without water bodies. In addition, continuing to what I said about the temperature gradient, ocean thermal conversion is mostly limited to just the region with the tropical climate. In order for efficient energy conversion, there needs to be a constant large temperature gradient of the seafloor and the surface. In the tropics, temperatures are high consistently. However, in the temperate climates, temperature varies throughout the year, and this causes a smaller temperature difference of the ocean and the surface. In polar climates, it's even worse. The temperature gradient is really small to be able to generate much energy. It is also an engineering difficulty and challenge to build structures that stretch all the way to the seafloor in order to collect water. Ocean thermal is also not energy efficient since huge amounts of energy are needed to circulate the seawater. Lastly, it also requires a lot of electricity itself to bring up water from the depths back to the surface.
Therefore, in order to fully optimize electrical generation using the natural energy from the ocean, we can set up an integrated electrical plant offshore that can harness electricity using both the waves and temperature gradients of the ocean. This is far more favorable for tropical countries whose temperature gradients are large. In order to make it even more effective, we can add another source using tidal energy to generate electricity. However, for countries with little or no water bodies, they cannot benefit much from these methods. I hope you have learned much from this video and will like to see you again. Remember to like, subscribe, and comment down below if you want to add on to the discussion. Thank you.